Okay, so we're looking again at the minimum temperature for winter time. So January 2016 minimum temperature. So we're just going to go ahead and download this one. The one you need for this is the BIL format. So do download data.bil. You don't need it for for the entire year. We just need it for January. And I'm just gonna label this as 2016 minimum winter. And I'll just show you how to go through one of these. Obviously, if you want to get the next year, you just change it from 2016 to 2015. Oh, they actually already have 2017 up as well. So like I said, it's pretty up to date. So then you just download the next one. So we're going to focus on 2016. So in order to transform this into that 3D model, we need to essentially convert this into a height field image. It's not going to work with this weird spectrum of colors. It needs to work off of a grayscale color scheme because height fields are made from black and white values. So we're going to go to QGIS. I'm going to delete these other ones. So I'm going to unzip that file. And I'm just going to extract it.
Would it help with 2017?
Sure.
The fact that they changed dramatically since 2016?
Go for it. Again, like I'm just showing you how you can take one of these, then you can just start to replicate this process for all the other ones. And then I'm also going to extract that ecoregion file. Okay. So now in this, I'm going to go back to QGIS and upload or bring in that raster file of my temperatures. So I'm going to go to workshop, vegetation, 26 min temperature. And I'm looking for the BIL file too. So it's this one. Again, it's usually the largest file. So I'm going to open that and it's going to actually come in as a grayscale image, which is nice. I just did 2016.
Temperature?
Yep, so minimum temperature, winter. Okay, so this is where it gets interesting, and this is where you really want to kind of understand or pay attention. So on the Prism website, it shows the temperatures in Fahrenheit, right? So I see degrees F, right? Everyone see that? So you have this legend that's saying these temperatures are in Fahrenheit. However, in QGIS, it's showing -16 and 6. That's Celsius. So we have to actually convert this to understand what it means. So we actually have to convert Fahrenheit to Celsius, not Celsius to Fahrenheit. So you're bringing in a rastered image. So again, add raster layer on the top left area. You're going to find your image that you just downloaded. Yep. Yeah, it's the larger one. So it should come in as this grayscale image, right?
There we go.
So like I said, that we have to convert these values to meet the range of temperature. So we have to look at, so let's go to Google and search Fahrenheit to Celsius. And so we know, again, what Prism's looking at is negative 11 degrees Fahrenheit. So we want to know what the lowest value is, which is negative 23.8. I'm going to write these down. Is that the good one? So negative 11 degrees Fahrenheit equals negative 23.8 degrees Celsius. Doesn't matter. And then the same thing, I'm going to look at the high temperature. So that is 79 degrees, which equals 26.1 degrees. So again, in order to make sure all our temperature values are matching, we need to essentially remap these values. We need to know what these temperatures are in Celsius. So we have them in Fahrenheit.
All of them?
Yep.
Really?
Well, we just have to do it for one, and then they're all going to get remapped, and I'll show you how to streamline that. So I'm going to actually just download one more. So I'm just going to download 2015, January. Okay. So in QGIS here, like I said, these values are negative 16 and 6. That's okay. That's just telling us what those minimum temperatures are, or that range of temperatures. We just need to kind of fit that within this spectrum. So we're going from, what was it again? So negative 16 degrees Celsius to 6 degrees Celsius. So we're really just, we're taking this kind of extreme values of like gray values. So here's white. Here's black. And then everything else is in between, right? So negative 16 and 6, we don't want negative 16 to read as white. We don't want 6 to read as black, right? We want 6 to read somewhere in between and negative 16 to read somewhere in between.
So, oh, because it reads only gray, it doesn't read white and black.
Exactly.
Okay.
So that's why, because when we compare this to another data, they're going to have different extreme values or minimum and maximum values. So if we remap them all to the same color range, they're all going to correspond correctly. So you could see, like, if the next one is, like, if we didn't go through this process and this one was 10 degrees, this was negative 20 degrees Celsius, but negative 16 read as black and negative 20 read as black, we compare that, they aren't going to match up, right? But if they all are reading black as negative 23.8 and white as reading 26.1, they're all gonna fit within that color spectrum respectively.
I got you. That makes sense.
So that's like why this is super important, but it's also easy to do once you do it for one of these.
So that's why you got their minimum and their maximum.
Yes.
On the website.
Exactly.
Oh, I was wondering what those have to do with those.
Yeah, because that's what they're all being based off of, is those degrees of Celsius. So like that map from Prism is going to give you that default range of values. When you bring it into QGIS, it's going to clip it at those levels. It's not going to read values that aren't there, right? Like this only goes to negative 16. It's not reading all those levels between negative 16 and negative 23.
So it's got this range and it's just moving in between the range.
Exactly.
That makes sense.
So we figured that out. So now we get to actually convert it. So I'm going to double click on that Prism layer. I'm going to choose it from being single band gray. I'll just do single band pseudo color. I'm still going to use a grayscale, but this gives me the ability to customize it. So again, render type, single band, pseudo color. And then this changes, like I said, so this minimum value is now going to read as what?
-23.8.
Negative 23.8. Then the max is going to read as 23.1 or 26.1, sorry. And now, this is the last thing you have to remember from this. You have to figure out how many classifications they use. So I see 3, 4, 5, 6, 7, 14, 21, plus 6, 27 classifications. Yeah. So I'm gonna now go, so I have my ranges of values, right? Now I need to know how many cuts or slices
So even
I need to make.
the model, you still put them in?
Yep. So I'm gonna now change it from, at this bottom where it says mode from continuous to equal intervals. I'm gonna change that classes to the right of it from 5 to 27. And now you'll see here's all my color classification. So now you'll see negative 16 point whatever fits within this gray tone, and that 6 fits within that gray tone instead of white or black.
How do you change the grades? I don't have that option.
So if you go to single band pseudo color, change the color to grays. Now hit apply, hit OK, and there's my new gradient.
So it's still showing the same information, you just adapted it so that it could be modeled?
Yeah, you're just changing it so negative 16 isn't black, I guess, in this case.
So disregard the fact that it looks different.
Yeah, it should look different.
Because the model's
Exactly.
going to show.
Because again, you can see that negative 23 is going to read as black and 26 is going to read as white. When I look at that, I can clearly see in this category 23.8. Well, let's invert it actually.
Inverted?
Yeah, it should be the opposite.
Oh, yeah, because that's going to show it sinking.
Yep, 27. So you can see 23.8 reads as black. 26.1 reads as white. Huh?
How do you expand it?
So you need to change the mode to equal intervals. Yep. And so you can see at the bottom or the top is black at 23.8. The white is 21.6. This value, if I look over there, remember this one came in with negative 16 and 6. So that's why negative 16 is reading as this tone and 6 is reading as that tone. Yeah.
So the map we imported had black as the highest.
Yeah, but that was...
But for right now, black has darker gray has to be lower than...
No, what you need to understand is that if it's reading as this is black and that is white, doesn't matter even if it's the opposite, that's not truly what that value should be, right? Negative 16 should be like in the gray.
No, I get that. What I'm saying is you inverted it because in right now...
Right, we want black to read lower and then higher temperatures read white. Yep. Okay, so now we got our new grayscale map. Let's do one thing first. So it's not the worst process to go through, but you can imagine how tedious this would be to do it for like 30 years worth of data, right?
I was hoping it was like every 5 years, 10 years.
So we could do, but regardless, it'd be tedious to have to like remap all these values, right?
You can say that?
Yes, we can save that. So what we're going to do is I'm going to go down to this bottom where it says style. I'm going to say save style. I'm going to go to my vegetation section, label it.
Winter.
Winter min style. Hit OK, apply, OK. So what's great is I'm going to go ahead and bring in another one of those BIL files.
Oh, that's right, you already downloaded it.
And now, again, I'm going to bring it in. Find that BIL. You'll see again, it's coming in as pure black and white and all those colors in between. That's not what we want because you can see they have different values. So I'm going to double click, go down to style, say load style, winter min style, open. Perfect. Got it. Got the new one. So you can see how they do change a little bit more. So you just have to click on the style down here and say load style. Find that style you saved.
Okay.
Okay, just like that. So you don't have to go through that same rigorous process. Okay, so let's get this into Rhino. I'm gonna go to my print composer. So I got my new composer. I would say just for the sakes of this, you might just want to try and watch. And I mean, you can try and follow along. I'll take my time, but just for the sake of making sure we wrap it up. So we have this image, right, in your composer. If things are looking white, there's two things you want to check. You want to make sure your composition page background color is set to black, and then item properties that you have your background turned off. If that's going to read as white, then when you do that height field, all of this stuff is going to read super high. It's going to read as its highest value, and it's going to totally distort your height field image. So you want to make sure it's reading as black, so everything's kind of projecting up from this black. So I'm going to go ahead and save this as an image. So this is 2016. So that's just a 200 DPI. And because of just the timing, I'll actually give you guys that script as well, so you can just plug in the surface and then we can edit it from there. So I got that. So now let's just change this solid color to white so I can see what I'm doing. I'm going to draw a rectangle that's 42 by 42 since that's what my composition was at. Again, I gave myself some buffer so it's not just stopping at 36 inches. I'm going to type height field. I'm going to find that one I just created. It's going to take a second. Then I'm just going to click on these corners. So it's good just to do the same resolution of whatever your dimensions are. So 42 by 42. The height I'm going to change though. I want that to be, in this case, 27 feet. 27 because we use 27 color classifications. I'm going to set image as texture, and then I'm going to interpolate surface through sample. So make sure you have this bottom one selected as your option. Hit OK. And there you go. So now you've got your temperature map converted into a height field map. What's great about that is I can then go to Grasshopper. This I think was from the last one. So temperature height field. This is again what I'll provide for you guys. I don't really need where is it? So it's running somewhere. There it is. So I could probably do around with the same thing for this. So this one is like precipitation for the previous group. But we can do the same thing for our temperature. In this case, I don't really need this part.
Is it the same thing that people from 2 years ago did?
Not quite. They had a very kind of simpler version, so to speak. So what I do want to do is make sure when I turn this on, I'm going to see that I have, oops, let's reference this surface. I'm going to notice I'm going to have a lot of points that are being distributed on this black, but we don't really need that because that's just going to kind of disrupt our information. So I do want to run one operation to it. I'm going to take the Z value. I'm going to say, find all my values that are greater than, this is set to 0, so I can do anything that's greater than 0.01. Oops, or let's just do 0.1. I can always increase that if I want. That's going to give me a pattern of saying which of these points are above that kind of cutoff point. I'm going to run the dispatch. I'm going to do that for both my points, so greater than or equal to. So there's the actual points. Then I also want to do it for my Z values. So I'm also going to use that as a list. This pattern, so now I got my A's, which are representing there. I probably should have turned something off real quick, but then I'm using my A value to my Z height also for these values. And you'll see that these circles aren't actually being distributed down there. Now you got your cool temperature gradient. Yep. And so what you could do is say, like, if you know what that height field is that's needed for that ecoregion, I can do you could. For now, though, I'm going to go ahead and do intersect, and I'm going to do contour, create a set of BR per contour. I'm going to do the contour X, because I think this way I can actually just give one height for that contour. So the plane, I'm going to create a vector. I'm going to say, in this case, let's say that zone is like around 7, the 7 classification 7. Or is that not working? What does it mean? You either have to specify distance or offsets. Well, let's see. Yep, there you go. So now you have where that height only exists, right? If I turn this on, you can see that's where that height is. So this is what you can use to kind of establish your new ecoregion. This is a contour. Yeah, you can, but you don't really need all of them. We just want to know, like, this is a temperature height field. We want to know, like, I want to look at this temperature. I mean, you could, for sure.
How do you show that in a graph?
You could say, like, if you were to then take your ecoregion outline and compare.
So they want to show all the ecoregions in that?
What do you mean all the ecoregions?
Like,
You want to do a contour through it all?
pretty much every
Yeah.
that might work.
Well,
And say that next time we see you pinning up, so
yeah, but
try to go as much into the logo and I get home for dinner, but
so there you go. So you could use this other contour component to figure out all your contours.
yeah, whatever. That's it.
Yep.
Oh, okay. All right, I don't have to do some work because it's holy crap.
It's a lot of,
It's a lot more than I thought.
yeah, but it's going to be pretty comprehensive, right?
So we're going for
So then you could even like start to colorize by whatever those colors are. So yeah, easy enough.